A model for the basal metabolism rate in kcals per hour of a young man is R of t equals 85 minus 0.18 cosine times pi lowercase t divided by 12, where t is the time in hours measured from 5 a.m. What is the total basal metabolism of this man going from 0 to 24 R of t dt over a 24 time period? So what are we looking for? Well, it's asking us to integrate the following. They want us to go from 0 to 24 of that R function, R of t dt. So let's replace R of t with the function that's given. So that means our problem is going to look like the following. We're going to go from 0 to 24 of the following function. We have 85 minus 0.18 times the cosine of pi t over 12 and that's dt. Okay, so now what we want to do is we want to determine what are we going to use for our substitution. We're going to substitute pi t over 12. So for step 2, we're going to let u equal pi over 12t. So now let's take the derivative of both sides. So du is going to equal pi over 12 dt. So if you notice in the problem, we do not have a substitution for that. So we need to then divide both sides by pi over 12, which is the reciprocal. So what we end up getting is 12 over pi du, which is going to equal dt. So now in step 4, let's go ahead and then rewrite this integral according to substitution. So we know that we're going to have 85 minus 0.18 times the cosine of u times dt, which is 12 over pi du. And then we also need to then rewrite our upper and lower bounds. So we know that u is equal to pi over 12 times 24, because that's what that bound is. And then we have u, which is equal to pi over 12 times 0. Okay, so now let's go ahead and continue. So we have the following. We have a lower bound of 0, an upper bound of 2 pi, and then we have 85 minus 0.18 times the cosine of u, and then we can factor out the 12 over pi times du. And so now the next step is to then take the antiderivative of both of these two terms. So we have 12 over pi times the antiderivative of 85, which is going to give us 85u, minus the antiderivative of the cosine of u is the sine of u, so this is going to be 0.18 times the sine of u, and we're evaluating that from 0 to 2 pi. Okay, so now let's apply our upper and lower bounds. So we have 12 over pi, and so the first one is 85 times 2 pi minus 0.18 times the sine of 2 pi, and that's minus 85 times 0 minus 0.18 times the sine of 0. Okay, so what do we get here? Well, we have 12 over pi times, well, we have 85 times 2 pi. So 85 times 2 is 170, so we have 170 pi minus, well, the sine of 2 pi is 0, so that's going to be 0 times minus 0.18, so that's going to be 0, minus 85 times 0 is 0, and the sine of 0 is 0 times 0.18, so therefore that is 0. And so what we have left is the following. We have 12 over pi times 170 pi, and that's over 1. So we can simplify the pi, and then 12 times 170 is going to give us 2040, and that would be 2040 calories. And there is our result.